get data from things like this or from this brain thing or noisy, and you can have idiosyncratic or even opposite things, opposite data meaning the same thing across individuals, as he was pointing out. How do you feel safe only querying when you feel uncertain? Because your machine could be totally certain based on the last 3 people who learned that when you're holding very still, it means you're very depressed. And then the last person is someone who, when they're depressed, pushes themselves into all sorts of, like, I don't know, jogging, physical exercise to try and break themselves out.
Yeah. So I think that that's something that would be difficult for us to study because we don't have a large enough population, but I would hope that with a big enough, I would hope that, if you were to think of this as sort of adapting not just toward an individual, but also propagating back into that universal model that we have, that those types of lifestyles or those types of signals would also kind of help that universal model that everybody starts off with when they're first installing this application. But yeah, I don't know. There's a lot that I'm interested in how this might allow a dedicated crowd of people to sort of assert their own knowledge of themselves back into the system. And that's really difficult to do without like that crowd, that dedicated crowd.
So I also have a question for Scott. So the data collection for this problem seems really difficult. You talked about some of the issues there, especially with mental health, with depressed and disengaged, and that kind of thing. And then so you were talking about experience sampling, and so experience sampling, in HCA in general, can be problematic because it's interfering, interrupting you. I think it's probably worse with mental health, right? Because the self-reflection, as we talked about, is something that will change your mood. So if you hadn't asked someone throughout the day how they were feeling, maybe you would have seen a different type, totally different, sensing data. You might have collected a totally different set of data. And I wonder if you've seen any of that, and how you might be dealing with that issue.
We've noticed connections just through our interviews with people. So a lot of our interviews were a little bit semi-structured. We had their data for that week, mostly when we'd go into an interview, we'd sort of do a review of the experience sampling answers. And, we could get a high-level sense of okay, they told us these were work days or something. And then, so we don't expect too much for a morning survey or an evening survey on those days. We'll ask them oh yeah, we got your survey this day, we got your survey that day. Was that work? You want to tell us a little bit about that? And that's when we started to see how individualized each person's lifestyle was. So we had the one person tell us I work in a call center, right? That was sort of week one's tell me about your life sort of thing. The next week when we really had some survey data to talk about with them, can you tell us a little bit more about this positive event that happened on that day, how that might relate to this stressful event that happened 2 days prior to that, something like that. And we'd sort of show them on our screen the data. They'd start sort of oh yeah, this one, they'd apologize as if we asked them to do homework or something, which was really, I don't want them to feel sorry for not, being able to accommodate our study, But then they'd sort of tell us a little bit more about, we'd learn a little bit more about it. We'd learn well, actually, my work starts about, 2 hours before midnight the day before, that kind of thing was really helping us to get at all the different complications here. It's interesting.
How do you manage the difference in time between when you send them a survey for a certain, you have uncertainty in your predictor for a certain time range,
So in our current study, so the work that we have done, it's really not an active learning system in its current state. There was very wide variance over when people would fill out the survey and when they were notified. We noticed that, so after we did that, we quickly were like, oh, we're really not accommodating people's lifestyles. We should give them the option to choose when they get notified. Right? So that was our next iteration. They choose when they get notified. And we found that people were actually changing that choice like quite a bit throughout the study. Further on, you'd sort of see that people would then, some people would actually go in without being notified and start putting in survey responses. They'd almost use it as like a journaling mechanism at that point, which was really not at all what we intended. So this is another interesting thing, right? Like, how do you account for people not using your experience sampling mechanism in ways that you intended? We're still getting more data out than we hoped for, but at their discretion, right? Yeah, I don't know, it'll be interesting to see how it works in an active learning system.
So maybe if there is a question for the other.
There's a recency bias here, I think.
Yes.
I have a question for Baptiste, but maybe Joel would have some perspective on it as well. So these systems where you have developed these models that are used for a creative application, I could imagine that your users would practice with them. And you said there was this co-adaptation aspect, so the users are getting better at exploring how those gesture variations can be accessed. So do you see then that there could be a cost associated with improving the model later, because that would sort of work against the user in some aspects in the practice they were in? Is that something you've explored?
It's something that I'm exploring now, actually. So the idea of learning through sensory motor learning and using this model to learn through that model. I think it's there's two things. First is I think variation in order to explore definitely facilitate learning. And in that sense, I think that kind of model, they could be adaptive in order to accommodate for what the user is doing. But I guess it has to, not to change over time, but more to be enough adaptive or to take into account the possible changes in the input. And I think it's they are good models because they are flexible enough to do that, and they are flexible enough to take into account the implicit variation that the user can put in the model in order to explore the possibilities and to learn.
So you think that even though the model would be adapting, it wouldn't necessarily destroy the user's experience?
Yeah, no, I don't think so. Well, it depends if you. It's not to adapt the model in order to completely change the interaction.
Yeah.
It's maybe to adapt the model in order to maybe propose or to widen the space of exploration, for instance. Let's say music, for instance. Maybe if you're a novice, maybe you would be a bit shy. You might not go at the limit of the system at the beginning. Maybe you would just try out to understand the mechanism of the system, but maybe you will want to go further. And in that sense, the model can adapt in order to give you more clues, in order to go further, to explore more the sound space, but without changing the way you produce the sound or your experience of the sound. Is how I see it.
So the work is quite interesting. So the user doing something, the sound goes there. So it's kind of like I can see that I'd like better if the user have some like expectation about when you do the gestures there. So it's kind of like quite creative stuff. Like if you could use this to actually create music. So I don't know if as a composer you're doing that things after you finish like for a period of time the pitch would like for 1, 3, 5, something like that. And after that period shows up is 3 or 4 or 5 could be, lots of possibility there. So sounds like, for me, it's kind of like different from the traditional machine learning. Like I search something, I definitely have some expectation. Like I search Boston, like I need something relevant to Boston. But when I'm doing these kind of things, possibly I won't have previous expectation about what shows up. So how do you envision this kind of difference between like the traditional human expectation without a very, I guess it should be like an exploration kind of stuff things. So balance with that.
Yeah, that's true that in this kind of applications, completely open-ended task, and we don't really know how the user will use the system, and actually we would like the user to use the system in a different way. But there are two things. One is I think is again this question of allowing exploration, which is quite difficult because you are dealing with non-predictable data. So you have to leave open, not to overfit to some data that you get, but more to leave open. So that's the technique we're using in the first model, the tracking, gesture tracking, which actually is like a continuous space that you can just explore. It's a continuous space made of change of speed, of size, and so on. There is no a priori knowledge on that. The other one is more, it's more so related to Rebecca's work, is where you build your system with your data. So the data, like I'm demonstrating variation, for instance, or so on. But the data is the way you want to build the system. So then you can, I guess, iterate in order to maybe to refine the system or maybe to change everything. And in that sense, the model here is more a way to. So you need a really fast interaction with the model in order to accommodate them.
So do you think this kind of variation, this type of like a creative kinds of human machine system is good or not? Or
Yeah.
okay. So variation can provide different like personal kinds of styles and different variety of content.
I think this notion of exploration is very interesting, and it's a little bit in all the talks that we don't really we are not sure that there is a solution to the problem, and it's kind of silly to ask the machine to learn it. It's more about that, it's more the human learning. The human learns about the problem through machine learning. And I would like to ask Joel about the exploration aspect. How do you see that? Why are you using machine learning at the end?
Well, so we did some kind of experience also with producing sound from gestures, and what we like is to give the user the ability to use the motion feature, so higher level feature, which can come from any like acceleration and so on, but it then can also come from machine learning, like deep neural network to do some kind of auto-encoder, and so this is your high-level feature, for instance. And so in some of the applications we built, we had a mapping between those high-level features and the sound that was produced and some qualities of the sound that was produced. And so we gave this to the user and let him explore. And so without a priori knowledge, he could see some visuals and some modification in the sound that was related to the high-level features of the gesture. So it was not gesture recognition per se, because he could do any kind of gesture he wanted, but then it would be the acceleration in his gesture or some higher-level feature in his gesture that was interacted through machine learning that changed the sound. And we could see that even though there was no a priori explanation of, okay, you should do that gesture in that way, and if you do it in that other way, this is how it will change the sound. And this pushed the user to actually try to explore and to do the motion differently and to try to do different kind of motions. And we had some informal talks, so this is still ongoing work, but before and after, And we could see that the idea that the user had about which interface he would like to build for himself really changed once he had used such a tool to explore features, because then he had access to features that he didn't even know existed, and by trying to do them himself just by embodiment in the experience, by being able to move and to actually feel how these high-level feature related to sound, he would choose some of the features that he had no idea existed before, and so become more creative in the way he would use motion to build new interactions.
But when you say user, you're thinking of the people who have first recorded the motion, or that somehow the designer or the artist who is going to use the application?
Yeah, more the artist that is going to use the application, because the first mapping of motion feature to sound was done by us, so we designed it, but so it was some kind of arbitrary, and we could even do it randomly and just provide it to a user and see how he take that system in hand and how he explore, and maybe there are some of the features that he will never encounter, and some of the change in the sound that he will never encounter because we did not give him a list of which features existed and how they would affect sound, but he would appropriate for himself the sound, and then he would say, okay, I really like that kind of effect, or that kind of gesture, but I would like it rather to influence that parameters of the sound and so on.
I'll ask a question to Sam just because it was a really dumb question that I'm feeling sorry for him. He got up there and he said, I really want somebody to show me. And I'm going to talk to you later about something, but just so I don't get too stupid in front of the group. But my question to you is this. I was really surprised that there are these people that have low oxygenation in the brain when they're high cognitive load.
Yeah.
People, can you explain? I would have thought there was a physiological model for oxygenation of the brain under cognitive load or something.
So there are two things that are going on here which are quite interesting. So the first is that there is a task-evoked systemic response in your skin, which is almost always going up during the state of high cognitive workload, right? So you can take this out of the signal, and so that you only get brain. So in most of the papers that you've seen, if you've looked at any FNIRS literature, they're not doing this, and so their results are in part telling you the story about the systemic response. So then, what is going on, like at a deeper level? The way I think about it, so this is uncharted territory, but I want to think about the brain in terms of like its functional networks, right? So you have the task positive network and the default mode network. So when I'm focused and I'm paying attention to the external world, my task positive network is working, and when I'm kind of lost in introspective thought, my default mode network is at work. And both these have neural anchoring at like pretty close areas. So like ventromedial prefrontal cortex has the default mode network, and then dorsolateral has the task positive. So I think they're kind of intermingled. And depending on where you put the sensor and a person's unique neural makeup, you might be probing either of the two. But it's like an unexplored question. It's interesting. It's fun.
So why not putting one here?
Yeah. So you better believe in my next, like when I'm sitting on the FNIRS myself, I put one right, so it's the end of the VMP, PFC, and then the other so it's on top.
But I'm going to need to stop. Because I thought it was interesting that in the four talks, I mean, we're not sure that the solution exists, and then you're hoping that there is a solution, but it's pretty clear that there is no clear solution.
Yeah, honestly, I don't think that we've looked at enough adaptively filtered data, right? And I just managed to implement this algorithm, and now I'm looking at all this data in this new light. So I'm hoping to find something, but I might search for something that doesn't exist.
But what you show in your talk is that you explore the data. I mean,
yeah.
You wanted to show about machine learning, but what you showed that you were exploring the data.
Yeah, well, I think we've got to do that one first
before you do the machine learning. You got to really understand these signals.
But you had some data which had a huge number of subjects, and you showed that on the average you had
Yeah.
a clear. So I wonder if you go through that data and you just take out, if you can work out which polarity they were, perhaps you can shrink down the variance in those.
Yeah.
Those ones.
Yeah, absolutely.
Be
Yeah.
cool to do that.
Yeah. Yeah, I will do that. See the characteristic of the opposite responders
That's
and the
right.
non-responders.
Take them out, filter, and get this lower variance.
Yeah. Yeah, I will do that.
Okay, we need to stop.
Okay.
So let's thank all the speakers.